Hello guys, welcome back once again. Today we are going to cover NAT, that is Network Address Translation. Okay, so before that, I just want to tell you that I have just bought a domain that is a freshdeveloper.online. So currently, I have just created a web page, this like CCNA dot php because I am just have developed this page, so it is not so good, not so fascinating. You might be feel that who has designed this page. Actually, I'm not so expert in design, web-based designing, but still, I have just given a hands on that. So I think you might be confused with the spelling. So that is very much like this: fresh developer dot online, not dot com. That is dot online, and you can put slash ccna dot php. If you are watching this page recently, so I am going to use this page. I have consolidated all the videos what we have delivered till now in this web page, so you don't have to find out that where is my video, or you can go step by step and one by one. So that's why benefit of this you going through this web page. Still, if in the future I might develop some other page, a better one, but as of now, this is very bad page, not so good. Just listed out the, or I think let me show you the, no, I just thought to show that how it is. So let me open it here. Fresh developer, yeah, that is the page, freshdeveloper.ccna.php. So here I have just collected all the pages, like whatever we have delivered till now, like network basics and all the parts. And till now we have covered day 24. Today I'm recording this day 25, and obviously I will put this bottom of this day 25. And these are just thumbnails for one or two. Earlier I thought to put all of them, but it's going to be so messy if I put all 24 like this one. So it has going to very difficult, so I just thought to put like this. Anyways, let's switch to our session today, where we are, right? So it's okay for the day, and let me jump to erase all the inks on slide. No, it is not erasing. Anyways, so let's discuss that what is our NAT. So network address translation is basically conversion of the one IP address to another IP address. Some of the people also call it as like private to public or public to private, but rather I prefer to say this line, one IP address to another IP address. That is actually a network address translation rather than saying a public to private or private to public, because sometimes what is happening that we are even changing from private to private. There is some requirements, then we are converting the private IP address to private IP address. Then also it is called as a netting, right? So let me just tell you that why we come to this technology and why actually we need it, right? So obviously, whenever we are having some topic or learning, then we should be aware that why are we using that one, right? So what was happening that if you talk about this IPv4 address, in the IPv4 address, we are having around 32 bits, right? That's quite clear that in the IPv4 address, we are having the 32-bit address. Now, if you convert the total number of IP addresses using the 32-bit, you will find out that you will get around 4.2 billion IP addresses. How much? 4.2 billion IP addresses. Now, if you just quickly, just recap in your mind, what is the population of the world? I am sure that some of you might not be aware, but let me tell you. Currently, in 2021, it is around 7 billion, or let's take the approximately 8 billions, 8 billion, right? And if we talk about this, when we introduce this NAT, that might be around, earlier it might be around the same. Let's take the same, it was 4.2 billion, right? And nowadays, what is happening? Uh, some of the people are using the multiple devices, right? You know it, right? Every device need one IP address at least for the connectivity. Even if your computer is connected, then it needs one IP address to communicate to the internet. If you are having a mobile phone, then your mobile phone need an IP address to communicate to the internet. Without IP address, it cannot communicate. Even if you are having smart TV, you're running an Android TV or some other OS TV, then also it needs an IP address to get it the internet connection. Then only you can watch movies on Netflix or Amazon Prime. If you don't have the IP address on your TV, you cannot watch it. And currently, even the CCTV cameras are having the IP address and they are being monitored from their IP address. So, in short, I just want to say that even one person is using more than 4 or 5 IP addresses. So, even we are using the multiple IP addresses and we are having the more number of IPs, right? Less number of IPs with the help of NAT, we can still use the internet. Although other solution was to implement the IP address IPv6, and obviously we are working on that one, IPv6. But still on that time when the NAT was introduced, most of the devices were not supporting IPv6 address. We cannot assign IPv6 address. So the for the short time NAT was developed that the till the time all the devices are not supporting IPv6, we will use this network address translation, and then we will slowly move IPv4 address to IPv6 address, and IPv6 address is 128 bit, and it is having so many of IP address, even uh, whole earth can have sufficient address and there will be no lack of IP addresses. But that till the time we completely do not migrate to the IPv6, we will use NAT. So you might be observing that currently most of the devices are supporting IPv4 address as well as IPv6 address. Even the mobile phones are supporting IPv6 address. So a time will come that we will slowly stop using IPv4 address and completely using IPv6 until the time we might not be using NAT as well. But as of now, we are highly using IPv4 address and we are highly using the NAT. Without NAT, you cannot imagine the internet, right, guys? So that is quite enough introduction about the NAT. Let's move further. We have quite gone through that what is NAT. NAT is basically IP address translation. We are mapping one IP address to another, one IP to another. So that's what we are going to cover. Actually, this is the topics we are going to cover. So that's what we are going to cover till now. I will just recap the public IP and private IP. Okay. And then we will have a look on the terminologies of NAT, like inside global, inside local, outside of global, and outside of local. So then we will have terminologies like static, dynamic NAT, and PAT, and then after that we will have a look on the lab that actually how actually the configuration is being done on the actual routers. Okay, so what is NAT? NAT is basically conversion from private IP address to not private, in fact, IP address one to another. I will not say that private because I have already told you that we do not say like that one, but normally it is being used in our case of internet. Maximum we do private to public. Maximum we do. But that's not the definition of NAT. Private to public. That's what maximum we do, but that is not the definition. And if even if we do private to private, then also it will be called as NAT. Okay, guys. And obviously, whenever we are having internet, right? So let me just give you an example. Let's suppose you are having one switch here, right? So this is our switch. This is your local home network. You are having two computers in your home, and let's say this is your device, right? That is called wireless router. Okay, and then this wireless router might be terminating on the some ISP, okay, router, and then it might be connected to internet. Let's say this is our internet. So there are two things, that is public IP and another thing is our private IP, right? So, or let me recap the private and public IP first, and then let's demonstrate this diagram. Otherwise, you will be little confusing. So let's discuss the private and public IP first. So in the range, this is actually a review of the private and public IP. I have covered this in the, I think, first or second session. I do not remember when I covered it, but we have covered it. But still, in order to understand it well, I thought to cover it once again. So private, these are actually what is happening, that whatever the IP addresses we are having. So from 1.0.0.0 to 9.255.255.255, that is a public IP. In between, we have given one private IP address that is starting after 9.255.255.255. If you increase one, then you will get this IP 10.0.0.0. You increment all the values and get 255.255.255, right? So till this in the class A, we are having this much range of the private IP addresses, and these private IP addresses are not used in internet, not used in internet. In fact, I should say in the global world, right? If you want to use these IP addresses in your home, you can assign one of the IP address from this range to your laptop, and you can communicate to another laptop in your home. They can communicate to each other, but you cannot use IP address from this range to communicate to the internet. You cannot. We discussed in the ACL, there is a implicit deny rule that these IP addresses are not allowed to enter the internet. All the ISP, that is internet service provider, they block this IP address. They put the rule as deny for these IP address. They do not allow it to enter. That's why we call it as a private IP addresses, and they are just made to use in private networks. Obviously, this is your home. My name is Anuj. So this is Anuj's home. So I'm using your name, might be something else. Let's say David, right? So David might be using the same IP addresses in their computers or in their home to communicate to each other. They will be working very fine because they are the private IP addresses. Even if you, let's say if you are using this private IP address here, right? And you are also communicating to the internet. The same time, my David might be using the IP address here, and that also might be communicating here. So there will be IP clash. Whenever any packet reply might coming, he doesn't know that whether he will deliver here or he will deliver here. Right? That's why the ISP are doing, they are just putting an implicit deny rule and they do not allow the private IP addresses to enter in their network. So how we will communicate to the internet? For that purpose, we will always use the public IP to communicate. Okay, only from this range. So if I try to, so these are just IP addresses from this range. These are the private. These are also private. I just want to show you that what is the IP address of my machine. ncpa.cpl. Oh, what is on numlock? cpa.cpl. Not here. Oh, it's opened. And this is my Wi-Fi. Thanks 5G. And let me see the IP address of this properties. And here I'm using IPv4 address. Okay. IPv4 address. Let me see the properties. No, I cannot see it here. How can I see it? Transmission control protocol. Oh, I forgot to check the IP addresses. How good it is, right? I do not remember how to check the IP address. Strange. I wanted to sue you here, but I think I cannot. I have to use my command prompt only. Properties, advanced, DHCP enabled, IP setting. I cannot see it here. Anyways, I have to go to the command prompt. And I have to use the command ipconfig. So this is my IP address. Where are my IP address? This is my IP address. My IP address is 192.168.29.52. So this is the IP address which is being assigned by my router. Right, guys? So this is just assigned via my router in my home router. Obviously, there will be broadband and there will be wireless router, and that has assigned me this IP address. Right? So this is I'm getting from this. This is my computer here, and this is being assigned 192.168 dot I think 29.52, right? That's what it is. Yeah, 29.52. 29.52. Now, if you observe it here, what is this range? 192.168.0.0 up to 255, they all falls in the private IP range. So obviously, this is my private IP. This is private IP, and this is just being assigned from my wireless router to me. And this wireless router will be connected to some ISP router, and that might be using a public IP. So what is my public IP that I can use from the Chrome? Let me search it here. Very popular question. What's my IP? And my IP is 49.36.190.7. Let me check it. This is my IP address. I'm using currently Geo. I'm in Delhi, National Capital Territory of Delhi, country is India. Right? So this is the IP v4 address is being assigned. And if you check this range, receive the latest news. No, I don't want to receive. Let me delete it here. Yeah. So that's what information they are providing to me. This is the public IP address of the geo. That's how I am connected to the internet using this IP address. If you check the range of this 49.36, where it is 49, 49, it comes in the class A, and here that is in the public IP. It will come something, it will be coming between 11 to 126 range, right? So that is the public IP. So that's how the internet is working nowadays, that we are using a private IP address, and then it is being converted to the public. Let me explain you here. So now this is, let's say this is our 192.168.29.52, correct? This is my IP address. Now what is going to happen? This is going to my broadband router. This broadband router, because, and this IP address is being assigned directly via my broadband router, and this request goes through this router. Okay, normally there's two ways: either it can be translated here or it can be translated here. It depends on our service provider where they want to translate it. It totally depends on our service provider. So now what they will do, they will translate this 192.168.29.52 in some other IP address, that is 49 dot I forgot it, but let me take it by default 49.1.1.1. It was some public IP, and it will be converted to this 49.1.1.1 IP. And using this IP, it will going to, let's say there is a Google server, right? Let's say this is Google. It will send reach to Google server. Now Google will reply back on which address? This 49.1.1.1, because this is the public IP, and they know that this is a unique IP, and these public IPs are paid. They are not free of cost. You have to pay for that one whenever you are buying any IP address. Whenever you are taking a lease line, you just pay just for one IP address. But whenever you're just taking the internet connection, you might be sharing this one IP address with the other users as well. So that's not your job. You don't care at all how this is happening, how you care, what you care, that you should be able to use the internet. But that's how it is. It is being mapped to some other IP 49.1.1.1. It is going to some Google server. Google is aware of this public IP, and they are replying back to 49.1.1. This router is having translation table. We also call it as NAT translation table. They are having table that we have received requests from 192.168, that has whatever the IP address it is, 29.52, and I have mapped that IP address to 49.1.1.1. So whenever I'm getting any reply to 49.1.1.1, I have to send this request to this IP address. So now this router sends that packet to this computer. So that's how the communication is happening in the NAT. Obviously, whatever I have told you is not full detail. This is just an overview. We have to go more deep on this NAT, right? Let's go. Let's go. Private and public IP, we covered that public IP is routable. on global world. They are paid. You have to buy it from any of the uh, ethnic region, wherever the service provider it is. There are a lot of IP address provider in your region. You have to buy it from there. This is not routable to internet or the global world. Okay, and we can say class B. Yeah, that's fine. And they can be reused. They can be reused. You are also using the same IP address, and there might be in other home or some other company, someone else might be using the same IP address, and they are unique. Nobody else will be using these IP addresses because they are unique in the global world. Okay, so there are some NAT terminologies, that is inside local, inside global, outside local, outside global. So to in order to understand that, let me take one router here. Okay, and let's say there's one computer here connected, and let's say this is our internet. You are using one IP address 192.168.29.52. Okay, you are sending request from it, that is being translated to some other IP address, let's say 49.20.20.20. Okay, and using this, it has communicating to some other Google server, let's say 8.8.8. That is the IP address of the server. You are very sure, right? Without IP address, we cannot communicate. So obviously, server might also having some IP address. So that is what's happening. Now let's understand that what is the inside, local, and all. So this is called a local, right? Because this is your router, and till this side, this is our local. So whatever this IP address it is, this IP, this will be called as the inside local. That's what it is saying. The IP, how inside address is seen locally by inside host. So inside host is our computer, and how this is being seen, obviously with the same IP address. Inside global is this is our global because this is a global site, right? So how globally they will see. So from the outside host, the internet, it is translated or natted IP of the host. So once it is being translated or it is natted, then what is the IP? So obviously this will be our inside global IP. If you talk about the outside global means this is our global, but we are talking about the outside global, right? Outside of global means hosts in LAN will use it as a destination IP address. Got it, guys? Hosts in the LAN will use it as a destination IP address. You can, if you do not understand it, just read it from the starting. IP is how outside address is seen locally by inside hosts. So from the lab perspective, it is a translated netted IP of the host that resides out of our network, like in internet, right? So I think this is a better netted IP of the host that resides out of our network to the internet. Perfect. Outside global. Oh, I think I was saying something wrong earlier, right? I was saying outside local global. I was saying outside global, but actually that is this one. I said it wrong. So outside local is this IP 49.20.20, right? Outside local is this. Obviously, outside local will be this, and outside global. And now this is very confusing. Outside global. Most of the time, what is happening? These two IP addresses are same. they are same. In 99% they are same. There is no change in that one. So this is the IP address. This is the IP address, real IP address of host that resides out of our network. Real IP address. So real means that how we are using it globally. That's how it is. Okay. If you don't understand, if you have any questions, do not hesitate to reach me. I'll be help you out. Okay. But that's how it is. So now it's time for NAT. There are three types of NAT: static NAT, dynamic NAT, and PAT, that is port address translation, or we also call it as NAT overload. But first, we are going to discuss our static NAT. So, what is happening in the static NAT? We are mapping IP addresses one to one statically. Let's suppose this 192.168.1.1 is being translated to 200.200.20.1, or let's put this 200 as well. And you have one more computer in your home, 192.168.1.2, that you have translated to 200.200.200.2, right? Same thing that might be having the third computer in your home, 192.168.1.3, and that is being translated to 200.200.200.3, right? So what is happening here? We are manually defining that whenever you are the computer, and whenever you are going outside of our network or going out to the internet, you will use this IP address and then you will use the internet. Whenever this guy wants to use the internet, what he will do, he will use this IP address and then he will go to the internet. If this computer wants to reach the internet, he will use this IP address and then he will use the internet. Then why we are using the NAT rather than we can just directly use this IP address on this computer and we can use the internet, right? So obviously static NAT is never used, and the total the waste of IP addresses, but still we have to know it. So I have just told you, but we never use it. Okay, so in the case of static NAT, we are mapping one to one, or there's a fixed mapping one to another. That is called the static NAT. Don't worry about the commands. I will just tell you one by one. Okay. Another type of NAT is like a dynamic NAT. In case of dynamic NAT, what we are doing, we are having the different computers like 1.1, 192, 168, 1.3, 1.4, 1.5, 1.6, 1.7. It might be the case that these three people work in the daytime in your office and the remaining people work in the night. And if you are using that static mapping, then obviously if that has been mapped to these three IP addresses, the remaining night guys cannot use the internet. The solution for that is dynamic NAT. In that case, what we do, we take the range of some of the IP addresses. Let's say I have taken the three IP addresses in the dynamic pool: 200.200.200.1, 200.2, 200.3. Now we don't have a fixed mapping for that one, that this 192, 168, 1.2 will use only this IP address. But how they will do? If this person, let me change the color. If this person wants to use the internet, what he will do? He will go to the router, he will take one of the IP address, and then he will go to the internet. Let us suppose if he wants to go to the internet, he will use another available IP address here, and then he will go to the internet. If this person wants to go to the internet, he will go to the pool and take the next available IP address, and it will go to the internet. Now this 1.5 also wants to go to the internet. It goes here and says there is a no IP address available. Now he cannot go to the internet. He cannot use the internet because there is no public IP available in the pool. He cannot go to the internet. Why I said that day and night case? Because in the day they used all three IP addresses. In the night time, these people are not using the internet. So obviously these IP addresses will be free, right? So let's suppose this person is not using internet and this is available for use. We are having one IP free here. So now what will 1.5 will do? Because this is free, this IP address free. So he will go to here. It will take this IP address and use the internet. So in the daytime, this person was using the same IP address to reach the internet. In the night time, this person is using the same IP address to reach the internet. So this is the benefit of the dynamic NAT, but still this is not so popular and we do not use it. Now you might be thinking, if you do not use it and these are the absurd technology, then why we are learning it? Sometimes we have to learn the basic things in order to understand the advanced things, right? So the most and commonly used is the PAT, or we also call it as NAT overload. PAT stands for the port address translation. So what's happening now? Let us suppose we are having 192.168.1.1, 1.2, 1.3, 1.4, 1.5, 1.6. They all want to use the internet. And we are having just one IP address, that is 200.200.200.1, just one IP address. And here we are having the internet. How they are going to use the internet? Let's see. The solution here is port. How the port is working? Whenever any of the computer is going to use the internet, what they are doing? They are translating this going to this IP address, and now this IP address is putting it in the port number. How they are doing? They are putting is 200.200.200.1, and after that it is putting some port number 551, and this request is going to the internet. If this person is going to use the internet, they will go to this again. It will be put another port number for the same IP address 200.200.1. It will take another port number 552 and it will go to internet. If this guy is going to use the internet, again it goes to this IP address and it is given one more port. This technology is given by the PAT, port address translation. Another request comes, it gives one more port number, let's say 49553, 49554. It keeps on giving the port numbers and using the same IP address. They are using the internet. So in real life, we are just using PAT, and that's see that how IP addresses are being saved using this technology, right? So we are having the so many IP addresses here, but in order to reach the internet, we are just using only one IP address. Correct? So that's why we said that with the help of this NAT, or in fact we should say the PAT, we sort out the problem of the deficiency of the IP addresses. We can have even less IP address, but still can use the internet using this technology. Okay, but you might be having one question in mind that how many ports it can have, right? Can we have the unlimited number of ports? No, we cannot. There is a limit. It is having only 65,000 or how many I don't remember. Let me just check it from the internet. Uh, Port numbers range. Yeah, 65,536. Port number range from this, right? 65,536 because they are 0 to 1024 bits only, right? This is the thing. So the problem I was telling you about that we are having only 65,536 ports. So obviously we can have maximum 65,536 computers can use one IP only, right? We can have maximum 65,000 ports. Only 65,000 users can have the internet using the same IP address. If you want to use more than these number of users, you have to use the another IP address of 200.200.200.2. You have to use another IP address. But in these ports as well, 0 to 1024 ports are well known and we do not use them, right? You might be having the words, right? The port number 80 is like HTTP. So that's also the same port number. Port number 80 HTTP, SMTP 25. So these are also port numbers. We are not using those ports. Port number for the NTP, Network Time Protocol. We are having the port number 123. We're not using that port number in order to reach to the internet having the PAT. We're not using that one, right? So 0 to 1024, 0 to 1024 is reserved. And let me search you the better way. Range in PAT. I think that will range in PAT for connectivity, or I think user defined source PAT. I think this should give the better. La, 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 la. No, it is not giving that. How many users in one? Yes, any uh, users in PAT NAT. Users in NAT in one IP. Network address translation NAT. I think this can give us better understanding, or it is still not what I'm looking for. Let me sort out the images. That may help us. Mhm, mhm. Da, 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 da. Okay, I'm not getting here. Anyways, I will just have a look and tell you. Okay, but still, actually, what is happening? Why I'm not saying the accurate word? Because there are some more range we did not use it. That range starts from something like this 45,000 or 40,000. That's what only we use it for the port address translation. Obviously, means it means that we are having limited range around 20,000, but I don't have the exact count that how many users can have single IP. But still, that's quite sufficient. And normally we use PAT for this purpose. Okay, so let me tell you a real life example. So that will make your day. Then we switch to the lab configuration of these. All three, I will take the example. Okay, let me take a router here and let me take a server here. Very simple architecture. Okay, and this is the NAT device. NAT device. Whenever what is happening, whenever you are opening any tab, let's suppose Chrome you are using. So once you open a new tab of Chrome, then it is let's suppose you hit facebook.com. So in that case, it is requesting facebook.com from your computer, and your computer is having an IP address, let's say 192.168.1.1. At the same time, you open one more tab in your computer and you hit, let's say, Ghana.com, right? Ghana.com is a website which just tells you the uh, music streaming website. So that's what you hit it on here in the second tab. So because both the tab are using the same IP address 192.168.1.1. So obviously how they will segregate the traffic, that which packet should go to the Ghana.com and which packet should go to the Facebook.com. So this is an inbuilt behavior of the Chrome. Whenever any request is generating, by default, they are putting a source port number after the IP address. So let's suppose they put the port number 20111. Okay, so this is generated from the facebook.com, and another one, let's suppose the same IP address 192.168.1.2, that is generated from the some other port number. These are the random ports number. We do not put in the sequence. They can be like 45113. They are the random ports number generated by the browser or any of the service. Even in the same time, your system might hit an upgrade of any of the software, right? So that will also be generated by any random port number. And this time we say that this is requested by the Ghana.com. So now this request 192.168.1.1.2011 goes to our NAT device. Obviously, this IP address is our private IP address, and this is having already a source port number 20111. As it comes to the NAT device, it will translate it to the 200.200, any of the IP address. I'm just taking any random port number, IP address, 200.200.1. So now what it will do, it will put another source port, let's suppose 48,533. 48533, and now it is storing this information in the network address translation table that I have mapped. It is like stored here. Let me write it here. 192.168.1.1 slash, or let me put it I'm just a little confused where to write it. Now this is mapped to this 200.200.200.1 colon 48533. correct? This is, let me create it like a table. We call it as a translation table. There's a one entry here. Same after a few seconds or within microseconds, you just hit another tab, Ghana.com. So it made another entry here, 192.168, 1.1, and using the port number 45113. And now it is being translated to 200.200.200.1. And this is not the random ports, they are just might be in the sequence 534. Fine. So now this is having the public IP address, and this is being transmitted to any of the destination port. Obviously, this is what port we're talking about. These are the source port. And the destination port, it might be type of the traffic. It is either a HTTP traffic going to the port number 80, or it is the FTP traffic going to port number 21 or 22, based on the type of the traffic it is. So it is going to different type of the servers or the type of the traffic it is having. These are the destination port. Okay. Now, based on the server, whatever the type of the server it is, it will reply back. It will send back the reply. It is replying back to which IP address? This IP address, public 200.200.200.1.1. This router is having this type of the table, translation table. It is saying that, okay, this server has replied. To whom it will reply? It will reply to the, including the port number. It means like this 200.200.200.1 colon 48533. Okay. So now it is check the translation table, and it checks that, okay, it is having an entry like this one, and this entry is mapping to this device. So now it is sending the packet to this device, and this device is having that information that this 2011 port number is going to which port, which tab, that is requested from the Facebook. So it will land to the required tab of your browser. So that's how the communication is happening in the real life, in the real environment. Although if you understand it, it's very good. If you do not understand, please watch it once again, because this is the very important. And if you are going for the interviews in a good company, not just a silly company, in a good company, they are going to ask questions like this. They try to know understand that, do you actually understand the packet flow of the network, how the packet actually travels, right? So please recap if you understand it very well. If you not, please watch it once again. If you have any questions, do not hesitate to reach me anytime. So that was the sufficient for the theory part. Now we will go for the configuration in packet tracer. Okay, let's move to the configuration part.